This meeting is now being recorded.
Hello all. Thank you so much for taking the time to join us this afternoon. You are here for a webinar on combined heat and power, a winning 111D compliance solution. If that's not the webinar you intended to join, now's a good time to jump off. As you just heard, we are recording both the audio and the slides for this call. So if you have colleagues who are hoping to join in, or if there's a section of the presentation that you'd like to hear again, I will be sending those links out to folks following the call. Let me just cover a few logistical details before we jump into the substance. First, as you've probably already discovered, your lines have been muted. That does not mean we don't want to have a good dialogue with participants here. So there's a few different ways that you'll be able to communicate with us throughout the call. First, if you have just kind of a clarifying question, or if you're having a hard time understanding or hearing something, go ahead and use the chat feature on the bottom left of your screen. There's a drop-down menu there, so you can either chat to everyone or to the particular panelist that you're having a question for. If you have a more substantive question, we are leaving time at the close of our presentation for Q&A. So up at the top middle of your screen, a Q&A bubble. Go ahead and click there. We are hoping to have time to address everyone's questions. However, there's a large number of folks participating in the call, and we've got a lot on the agenda. In the event that we do not have time to cover your question today, we'd be very happy to answer it offline, and we'll make an effort to do so. So please do take the time to submit so that we can continue this dialogue even after today's webinar. If for some reason you have a technical problem on the call, for some reason maybe the slides aren't showing up or you're having a hard time hearing, there is a question mark on the top right of the screen, and if you click there, it'll open a dialog box where you'll be able to chat with folks from the web conference facility to your problem. So I think that is all of our logistical issues, or those are all of our logistical issues. Let me go ahead and give you a quick overview of what we hope to cover for the next hour. I'm going to kick things off in just a moment. My name is Jennifer Kefer, and I'm Vice President at Gardiner Associates, and I run a group called the Alliance for Industrial Efficiency. And I'll be opening up with some kind of broad overview of how combined heat and power is treated under the climate plan, highlighting a few specific quotes from the rule and some areas where there might be some opportunities. The bulk of our conversation, however, is going to be for our colleagues from both the American Council for an Energy Efficient Economy and Center for Clean Air Policy. They'll be providing a report on the analysis that they've about potential CHP deployment that might be realized from the 111D rule. You'll be hearing first from Sara Hayes, a senior manager and researcher with ACEEE, and then Dan Trombley, a consulting analyst also with ACEEE. And they'll be talking about their recent work, followed by Stacey Davis, who is a senior program manager at the Center for Clean Air Policy. There will be links throughout the presentation on the slide so you could track down the actual analysis. Also, if you go back to your calendar invite and the registration, there is a link to both reports there. One final thing, I mentioned that even though your line is muted, we do want to have a dialogue here. So again, I do encourage folks to click on the Q&A button. But additionally, the final slide today will include all of our contact information. So if there's, if you want to get kind of more down in the weeds and you feel like we have time for on this call, we encourage you to reach out to any one of us. I know we'd all be very happy to speak with you. So with that as background and the overview, I'm going to go ahead and jump in. And as I said, my goal over the next 15 minutes is to kind of give you some broad brush stroke overview of how combined heat and power is treated by the rule. So my first slide here I think is rather striking because this is actually one of the ways that CHP benefits from the rule, but there's not necessarily any explicit mention of CHP at all. If EPA had proposed a source-based approach, there would be no reason for us to have this conversation. We'd basically be limited to the left side of this slide here, and we'd be looking just at what the affected units, the EGUs, could do within the four walls of their facilities. There'd be a small handful of very large-scale CHP systems that would be affected. Those would be systems that produce more than 25 megawatts and sell more than a third of their power and more than 25 megawatts back to the grid. But there really wouldn't be a lot of opportunities for kind of innovative, really thinking outside the box policy measures. It's because EPA adopted or is proposing a system-based approach that it even makes sense to have the conversation that we're having over the course of the next hour. And that's what brings in all of the ideas depicted on the right of this slide here. Combined heat and power, energy efficiency, renewables, they're all on the table because we have a system-based approach where EPA has kind of recognized the reality that emissions at power plants are affected by energy use in our homes, our offices, and in the industrial sector. To the extent that you've got CHP systems that are on the left side that are affected units, they are going to have relatively lower compliance burden because they're more efficient, cleaner units, and so then we'll have less to reduce. There are some benefits, though, for the CHP systems that are not affected units. First of all, to the extent that the rule does have any impact on electricity prices, and I think that's certainly, the degree of that is certainly up to debate, the hit that it will have on these facilities is going to be lower, one, because they're cleaner, and two, because they could produce their own electricity, and so are insulated from volatile energy prices. In fact, the fact that these facilities can reduce emissions could become a source of earning revenue dependent on how a state decides to move forward with the rule. What I think is potentially the biggest benefit for CHP is we all know that one of the biggest obstacles to combined heat and power and waste heat to power are unfavorable utility barriers, heavy standby rates, burdensome interconnection processes, the inability to net meter. Because under this rule, EPA contemplates that the affected units are going to be able to look outside of the power plant to reduce emissions. For the first time, I think it kind of alters the business model where CHP may be seen more as an ally. And so you might have actions taken as part of the compliance process for this rule where the EGUs are looking to figure out how to encourage more CHP deployment as a way to reach the reduction targets. So that's kind of one of the ways that CHP could benefit from the system-based approach that's adopted in this rule. My next slide here depicts another kind of implicit way that CHP benefits. Given our limited time today, I am not providing an overview of where 111D fits into the Clean Air Act. I'm assuming that folks have participated in other discussions over the last 2 weeks that kind of provide that basic background. But one thing that I'm hoping folks recognize is that EPA has set targets for each of the states and then now defers to the states to develop their state compliance plans to figure out how to achieve those targets. And the state targets were set taking into account 4 basic building blocks. And while in the title of those building blocks, the word CHP is not explicitly mentioned, CHP has a role to play in achieving any one of them. So for the first, heat rate improvements, this would, if you consider your large CHP systems, these affected units, you could imagine them making on-site improvements to their heat rate. Shifting dispatch, increasing the use of natural gas units. You could imagine a natural gas-fired CHP system adjacent to a thermal host that might be getting some more use because of this rule. You could have renewables fueling CHP, like a biomass CHP system, which you have a lot of, for instance, in the paper industry. And then finally, the last building block, which perhaps is the most obvious bucket to put CHP in, it's demand-side energy efficiency. I think one of the things that we're really hoping a lot of states consider as part of their compliance plan is expanding or adopting portfolio standards that recognize combined heat and power and waste heat to power as a way to achieve their goals. And that on its own will create a lot of incentives for building out those technologies. So I guess though CHP is not explicitly mentioned as part of each of these building blocks, it really does have a role to play in achieving any one of them. But there's also more explicit treatment of CHP in the rule, and I want to cover a few aspects of the rule where CHP is addressed either explicitly or benefits from the design of the rule in this next slide here. So first, EPA has adopted what's known or has proposed what's known as an output-based emissions standard. The standard is a rate-based approach that's written in terms of pounds per megawatt hour. Now, historically, that has not always been the case. Traditional Clean Air Act regulation is based on the fuel that goes into a process rather than what you're actually producing from it. And that tends to discriminate against energy efficiency generally and CHP in particular. As I imagine most of the folks on this call know, the key benefit of CHP is that it's producing both thermal energy and electricity from a single fuel source. So you're producing more with less input. By having an output-based standard, you're recognizing the full output that come from a CHP system. And when you look at it, thinking of the basic math of it, it's written in terms of pounds per megawatt hours, you're getting more in the denominator because you have both the thermal and the electric, which then makes the relative emissions from a CHP system appear smaller. Next, there are several quotes in the rule that explicitly mention CHP. When you have access to the slides, you'll see the full quotes here. I've got the pin sites written in, though I just realized I think the pin sites are actually to the pre-publication version, so I need to update this to give you the Federal Register page numbers. But in any event, EPA says large energy users might consider CHP, and states can include it in their plans. So I think this is a really promising statement, a very encouraging statement from EPA, that large industrial users, your paper mills, your chemical manufacturers, might see some energy efficiency opportunities to include CHP in the state compliance plans. What's more, EPA goes on to say later in the proposal that distributed generation has reliability benefits. They actually say demand-side management, like distributed generation, such as CHP, has reliability benefits. So, for one, EPA is recognizing that there are substantial reliability benefits associated with CHP. It puts less pressure on transmission and distribution lines. It creates some resilience against extreme weather events. So for all of these reasons, CHP enhances resilience and reliability. What I think also is very attractive or encouraging about this quote is CHP is explicitly identified as an example of demand-side management. Throughout the rule, EPA talks about demand-side management and energy efficiency dozens, hundreds of times. It's like centerpiece of the rule. CHP is only mentioned a handful of times. One thing I think that folks can try to clarify in comments is that energy efficiency is in fact being used as an umbrella term that is intended to capture CHP. Because if that's the case, you could see again how CHP is really just woven throughout the entirety of the rule. Finally, in the technical support document accompanying the proposal, EPA lists a number of technologies for which measurement and verification is well established, and CHP is included on that list. I think that sends a very strong signal to states, along with the other quotes that I mentioned, that CHP is something they should think about including in their compliance plans. And so while the states have a lot of autonomy and flexibility to figure out what their plans actually look like, EPA has kind of put their its thumb on the scale and said CHP is something you should be considering. And that makes a lot of sense because EPA has told us in the past that CHP can produce electricity with 1/2 of the greenhouse gas emissions of the separate generation of heat and power. We also know that combined heat and power is a very cost-effective approach to emissions reductions. What you see on this slide is a graphic from the Business Council for Sustainable Energy's fact book, which came out this past winter. And along the y-axis there, you've got depicted a whole bunch of different clean energy technologies. CHP is right near the bottom of that list. And then across the bottom, you've got the different costs for energy from each of those different sources. And as you can see, CHP is lined up right as among the cheap sources of clean power. Consistent with this, DOE and EPA came out with a report about 1.5 years ago where they had some data that allowed you to determine the cost per ton of emissions reductions. And strikingly, combined heat and power came out really, I don't know if you call it the front of the pack or the back of the pack, but the cost for reducing carbon emissions with CHP was less than 1/6 the cost of distributed solar and 1/2 the cost of reducing that same amount of emissions with wind. And that's in large part because CHP systems can run around the clock. But so we know it's cost effective and it's a way to reduce emissions. There's a lot of reasons why this is an attractive technology or that states should consider incorporating into their plans. However, despite all of its benefits and despite kind of the very encouraging shout outs to CHP, there are a few outstanding issues that I want to touch on briefly before we talk about the ACEEE and CCAP analysis. And these are some areas where I think that we might want to weigh in with EPA and either seek clarification or seek some strengthening in the rule. First, at one point, EPA questions whether industrial CHP, quote, warrants consideration to avoid affected power plant emissions. And they specifically request comment on this. Well, this seems to kind of fly in the face of one of the quotes I gave earlier, which suggested that large energy users might consider incorporating CHP or adopting CHP as a way to reduce emissions. However, rather than seeing this statement as a negative, I think it actually provides a tremendous opportunity. EPA is inviting comment, so we are being encouraged to put into their record examples of how CHP actually does reduce affected EGU emissions. And so I think that's really a great invitation to provide some of that data for EPA. Additionally, I think this question reflects a sensitivity from EPA that I've been hearing from some industrial folks, some of you who are on this call today, about what being proactive might mean for a future NSPS. So this current rule is only regulating EGUs, but somewhere down the road we're going to have another NSPS for refineries and chemical manufacturers and people, the paper industry, and other portions of the industrial sector, and there's some sensitivity as to, okay, well, what happens if one of these folks installs a CHP system as a way to reduce airshed-wide emissions to help out the EGU, but the reality is that that is going to modestly increase emissions on site. And so those facilities are going to need some kind of assurance from EPA that they're not going to be penalized down the road for their early action. And I think that this question in the rule is, EPA's way of soliciting some input from us as to how they might be able to provide those assurances. The next bullet here is about the thermal output. As I mentioned before, one of the chief benefits of CHP is that it produces both thermal energy and electricity from a single fuel source. And EPA, in its definition of net electrical output, recognizes both products. So that's great. However, it then proceeds to discount the thermal energy by multiplying it by 75%. So you've got a 25% discount. That means, if you're looking at pounds per megawatt hour, that the denominator is going to be smaller than it should be, which will make emissions from those systems appear larger than they should. That's ostensibly being done to be consistent with some other EPA rules. The 111B proposal, for instance, also has a 75% multiplier for thermal output, but there are other EPA rules that do provide full thermal credit, and we think it's extremely important that EPA provide full thermal credit in this rule as well. Strikingly, the rule does seek comment on an alternative range, a range from 2/3 to 100%, and then says, let us know if that's needed to, quote, better align incentives with avoided emissions. So there's some recognition on EPA's part that there might be a different factor, there might be some policy reasons why you might not want to discount thermal. And so I think that leaves open the opportunity of having a full thermal credit both in this rule and in 111B. So I encourage folks to weigh in on that as well. And then finally, there is no mention of the phrase line loss credit or avoided transmission and distribution losses. But in that same definition for net electric output, you multiply the number by 95%. So you're getting a 5% line loss credit to reflect the avoided transmission and distribution costs that come with distributed generation. That's wonderful. It's something we hope states pick up on when they figure out how to count for CHP as well. However, avoided line losses are substantially higher than 5%. EIA tells us that on average, nationwide line losses are somewhere from 6.5%. So we'd want to encourage EPA to use a more generous line loss credit as well. And while within the contours of this proposal, this line loss credit and thermal output only really have implications for the affected units, it has implications that go far beyond that as states begin to develop their plan and look to what EPA has done here to figure out how they should be crediting CHP as well. So with that, we're going to turn now to hear a little bit more about the modeling that has been done by ACEEE and also by CCAP to see what kind of CHP we can expect to get from this rule. And I think they'll talk a lot about the assumptions and the results in their analysis. As you know, the President did issue an executive order seeking to get 40 gigawatts of new CHP by the year 2020. And as you'll hear from Sara and Dan and Stacy, it looks like this rule could take us a good step of the way forward. Their analysis, by the way, uses very conservative assumptions. And so with more, ambitious assumptions, those numbers could be even higher. And what's more, if states adopt favorable complementary policies, I think you also could see much greater development than the figures that we're seeing in this initial analysis. But I will now turn to Sara to provide a little bit of background about their study.
Thanks, Jennifer. Can you hear me all right?
Perfectly.
Okay. So I'm going to just talk very briefly, and then Dan Trombley is going to get into more detail about what it was we actually did. I'm going to try to advance the slides now. Nothing's happening. Let me try this. Aha. All right. So here's our standard slide describing who we are at the American Council for an Energy Efficient Economy, and in the interest of time, I'll just let you look at that later. What we did was we tried to answer the question of within the boundaries of what the language in 111D requires, what could efficiency do? What role could it play? And so we're not answering the question, what is the economic potential or the technical potential of end-use energy efficiency. Instead, we're saying, we're thinking about the terms adequately demonstrated, which is a phrase that must be met under the law, and we're thinking about costs, and we're thinking about some of the factors that EPA might consider as issues that must be addressed when they're designing the proposal. And also keep in mind we did this analysis before the proposal came out, so it's possible we might do it a little bit differently now, but actually we're pretty happy with how closely what we did compares to the analysis. So while it's not an exact comparison, you could dig around in here and get some sense of what role efficiency might play in the overall rule in a way that's a little bit different from how EPA has talked about it. So what we did was we looked at a combination of 4 efficiency policies. One is an annual savings goal. The other is combined heat and power. Then we've also included building energy codes and appliance standards. Our analysis starts in 2016, ends in 2030. And these are the high-level 2030 results nationally. You find that costs are a lot less than the savings. You find that about 600 million tons of carbon dioxide would be avoided in 2030. And if you are thinking about the rule, they're estimating in 2030 about 550 million tons. So again, it's not quite apples to apples. The way they estimate their emissions reductions are quite different from how we do. But if you're trying to get a sense of the order of magnitude of what these policies could get you, I think you could kind of draw some conclusions from that. We also did an economic and jobs impact analysis, and with the implementation of the 4 policies as we've laid them out, we'd see a creation of 611,000 net new jobs in the year 2030. And this is another way to look at some of the numbers that I just mentioned, as well as some of the additional results from the report. You see at the bottom right a $17.2 billion increase in GDP. Again, all these numbers are in the year 2030. It ramps up from the beginning all the way through. You see some NOx, SOx, pollution reduction, some offsetting of power plants. You can get a lot more detail in the report, and I'm going to just, again, in the interest of time, go quickly through this. The last point that I wanted to make is that while I've given you some national numbers, we have numbers for every state. I couldn't fit them on a single slide, but instead here I've provided some geographic estimates based on summing and averaging of the totals that we have for all the states. And what this is a percentage of the electricity savings that that our incorporation of our policies would yield. So in 2030, you would see these significant reductions across every region. The real point here is that there's no place that doesn't have efficiency. there's a lot of opportunity. Whether you've done a lot already or you haven't done much so far, this opportunity exists throughout the nation and in every state. I'm going to turn it over now to Dan to talk a lot more about what we did on the CHP portion of the analysis.
Thanks, Sarah, and thanks, Jennifer, for having us on the webinar today. So for the CHP section of our analysis, I will talk about two aspects of it. The first, how we forecasted the total installed CHP capacity in 2030, and then a little bit about how we attribute energy savings to CHP. So how we can draw parallels between energy saved through combined heat and power, which saves primary energy, to end-use energy efficiency, as we showed in the rest of the other models in our report. Also, let's note that we didn't model a specific policy here. We're just trying to, in this case, we're trying to get a sense of what the potential is and how much is likely to sort of happen economically, using some pretty conservative assumptions. The idea just being that, just to show what is very possible to happen, so that, something that you can count on happening. So it's relatively low results here for conservative assumptions. So we took the basis of our study is based on a study from ICF. They skipped ahead to this report that they released in 2013, the opportunity for CHP in the U.S. So for the commercial and industrial sector in every state, they provided a technical potential for CHP, and they grouped that CHP into bins by economic payback. So this is the sort of base data that we use to kind of model how much we think it's going to have going forward. So this is just technical potential in the year 2012. There's no ramping up, no looking at new opportunities here. They just looked at waste heat recovery, so no, just topping cycle traditional CHP. This model sized the systems, the theoretical systems, based on heat load. So there's no electricity export, and they limited CHP system sizes from 100 kilowatts to 100 megawatts. So this cuts out some very large units, which is okay with us because we, as we talked about before, these large units are these units that export a lot of electricity, aren't really going to be creditable under this under 111D in this same way. So we don't really want to look at those anyway. Just kind of look at our advantage. The ICF study also provided a group of that technical potential in the size bins for every sector and state. So this is just a little overview of the different operating characteristics by the different sizes and technologies. And so we use that kind of spread for each sector and state to create a weighted average to get a sort of a typical system that we use for our calculations. So I'm going to jump back here. So we took that technical potential, a group of economic bands, as we talked about, and we applied an acceptance curve to that. The bin paybacks are kind of fuzzy based on some of the data in there, but roughly speaking, less than a 4-year payback around there was about 75% acceptance. Around a 5-year payback is about 60%. 5 to 10 year payback by 25%, and so on. To give you an idea of where we are, we'll see in the next presentation that this is a little more aggressive acceptance rates than PCAP did, and theirs partially drives the difference. But one of the reasons we did that was because, like I said, we didn't model new opportunities, so it partly accounts for that, and partly accounts for, I think, decreased costs with the CHP systems going forward. We didn't really model that either, so that's one of the reasons it was a little bit more aggressive on the acceptance rate side. So for every state and every sector, we have a sort of what we call a planned installation. We think that this is the potential, this is really what's likely to happen, and we kind of spread that over the entire study period evenly. So if the commercial sector at a given state we thought had 150 megawatts of potential, we would assume that was 10 megawatts per year for those 15 years in the study, and that's how we did that. We also then took each of those 10, each year, we did a separate cost-effectiveness screening to account for changes in energy prices. So each state has a slightly different typical CHP system, and they also have different energy prices, electricity and natural gas prices for the commercial and industrial sectors. And so most energy price forecast will show that, well, there kind of a futile attempt ever to forecast energy prices, but something we had to do. And most of the agreements show that the electricity forecasts are going to rise moderately over time, and natural gas and fuel prices tend to rise a little more quickly, especially with recent crashes in the shale gas and whatnot. So by the 2030, the prices are going to rise a little bit faster. This is disadvantageous than CHP in the long run, this increase in natural gas prices relative to electricity prices. So a handful of states and sectors decided to limit some of the CHP potential in those outer years. So that's our CHP forecast. So some of the top-level results. At the bottom number there, about 20 gigawatts of new CHP we think could easily be installed here. A good portion of that is in New York and California. I just able to show the top 15 states and total capacity, just to get an idea of where the spread is. Massachusetts, Jersey, and Texas all have, joining New York and California, all have over a gigawatt of potential, we think. So it's pretty spread out, although there's some concentration in the top few states that you might expect. That kind of gives you an overview of where our capacity lies. So now I want to talk a little bit about attributing energy savings. So there's kind of two things you need to look at. First is the primary fuel savings, which is, I think, pretty straightforward. A 100 megawatt CHP system is going to avoid a certain amount of kilowatt hours from the grid, and it's not too difficult to estimate how many the primary energy that went into the power plants that was saved going into the power plant, which is much greater than that. But then we also need to account for the increased on-site fuel. And should I just say that we assume that all of the CHP units we're installing are natural gas, just as a simplifying assumption. Just so you're aware of that. So then the next thing we wanted to do is kind of answer the question, how much end-use energy efficiency would you have to implement to generate the same amount of primary fuel savings you get from CHP? So you can't just look at the megawatt hours generated by CHP and say, call that the savings, because you also need to account for this on-site fuel, increase in on-site fuel. So we converted that primary fuel savings to end-use savings by using the regional grid average heat rate based on EPA data. So somewhat discounts the total electric output of the CHP system. But that's would be a fair way of comparing end-use energy efficiency to the savings from the CHP. I think that's about it for our overview. We do have a few more calculations here. I'm going to hold off on that. If there's questions, maybe we can go back to those things here just to demonstrate some of that. So our study is, you can download here at our website, and here's their contact info. And so we'll pass it over to next presenter.
Great. Thanks so much, Dan and Jennifer. And I also wanted to remind folks that if you have questions, to use the Q&A feature at the top of this screen, and we can respond to the questions either during the call or potentially afterwards as well. So just to start right in, I wanted to acknowledge the Energy Foundation, American Gas Association, ExxonMobil, Minnesota Power for their support for this analysis. This is a new modeling study that CCAP conducted using the integrated planning model to assess how combined heat and power can support compliance with power plant greenhouse gas standards. And this, as was the ACEEE study, this was done before EPA released its proposed rules. So, some of the assumptions were just guesses as to what EPA might be doing. But we can talk about some of the differences if folks are interested afterwards. This work also benefited from a multi-stakeholder modeling advisory group that guided us on the assumptions and the scenarios and on whether the study design was likely to achieve the stated objective. So we appreciate their input. And just very briefly on CCAP, we work with leaders around the globe to devise and advance cost-effective policy solutions that support a healthy climate and sustainable economic growth. So I have to advance study that way. Okay, great. So starting with our conclusions, some of the key takeaways from our study is that if combined heat and power is included as a 111D compliance option, then 111D will encourage combined heat and power, especially in states likely to experience higher than average carbon prices. And I should say that the total CHP that we do get as a result of our study is different. It's lower than what ACEEE found. And as Dan had mentioned, it's largely due to different assumptions on how frequently economical CHP will get built. And so I'll show you the curve that we've used a bit later, along with the other conservative assumptions as part of our analysis. Also, we found that CHP can support achievement of the proposed standard at a lower cost. And then, of course, these new investments in CHP do create new winners in states, particularly Midwest states and southern states, companies that manufacture and install CHP, the manufacturers that use CHP, and benefit from energy savings. And so we think that CHP should be included as a means of compliance alongside other clean energy sources because of these emissions reductions, because of the lower costs, and because of the additional winners that it would create. It doesn't make sense to leave good compliance options on the table. So the basic study objective was to look at how combined heat and power can support state compliance with EPA's guidance on regulated greenhouse gas emissions under Section 111D of the Clean Air Act. We were, of course, also interested in understanding to what degree 111D would encourage cost-effective solutions, particularly combined heat and power within industry. And so we did two policy runs to evaluate that. In each case, we used the integrated planning model as our dispatch model, working with ICF International, and also integrated that with their combined heat and power model, their CH power model. So basically what we did is we would first run the IPM model. Outputs would include electricity prices, natural gas prices, and carbon prices. The carbon prices would only be in our policy case. Those would be inputs to the CH power model, which would be run. It's a representation of the potential CHP across the country. They would look on an economic basis how much CHP would be economical given those prices, and then the total economical and accepted CHP would then be plugged back into IPM in special modules for that. It's the run before. And so that's how we incorporated combined heat and power into IPM on an economic basis. So just a bit more on the CH power model. It includes 125.6 gigawatts of potential CHP units across the U.S. As I mentioned, it forecasts based on the economics how much new CHP is likely to be installed in each state. And it also looks at rates of market acceptance, acknowledging that end users may not opt to make investments that are otherwise economical. And then also we assumed rates of market penetration. So we didn't assume that all of the CHP would come in instantaneously, but that it would come in over time, over roughly a 10-year period, looking like an S-curve. So just to give you a sense of where the technical potential is on a state-by-state basis, a lot of it is in California, Texas, and then the Ohio to New York region, but also there's a big swath of the country all the way from Wisconsin to Florida that has a significant amount of CHP potential as well. We assumed similar costs to what ACEEE used, although these were updated using EPA CHP partnership numbers in 4 different size classes. For each size class, we assumed the lowest cost technologies. So this would be reciprocating engines in the smaller size classes, gas turbines in the larger ones. And so here are the acceptance curves I made reference to previously. These are based on 2003 Distributed Energy Market Survey results that differentiate for industrial units as well as for commercial and institutional units what their likely acceptance rate would be given different payback years. And so at a 2-year payback, we assume that only roughly half of industrial users would accept the CHP investment, whereas for commercial and institutional investors, it would be upwards of 80%. And obviously, in both cases, as the payback terms increase, the likelihood that they're going to invest goes down, so that after 10 years, no one's likely to invest in new CHP. Some of the other assumptions that we used, like ACEEE, we assumed no electricity exports, and therefore the new facilities were size limited based on not exporting electricity. We also assumed that all new facilities were fueled by natural gas, although of course we know that some CHP units are fueled by lower cost fuels such as waste or biomass, where facilities have access to those lower cost fuels, and so, but we assumed that those weren't available. We also didn't consider some of the secondary benefits of CHP, such as business resiliency and grid stability. We assumed that CHP units would continue to pay utility providers 15% of the earlier rates for continued access to the grid as backup power. We didn't look at the extra emissions reductions that result when you switch from an existing coal-fired boiler to natural gas-fired CHP. We simply assumed that those opportunities were essentially used up through compliance with the industry MAC. We assumed that the investment tax credit for CHP would expire. We also, and this is different from ACEEE's study, we assumed that the emission credits to CHP would be awarded based on a comparison with a state standard, not the marginal emissions reduced. And so for states that have more coal on the margin and would have potentially higher emissions reductions, we were somewhat conservative in terms of our assumptions. So we looked at two different scenarios, a base case and a policy case. In both cases, we built from NRDC's existing scenarios. We used their updated reference case and added CHP to that to make our CHP 111D base case. And then for our policy case, we built from their moderate constrained efficiency scenario, which did assume emission standards were developed for each state, a single emission rate based on historic natural gas and coal in the state, and those fuels were benchmarked to 1,500 pounds per megawatt hour for coal plants, 1,000 pounds per megawatt hour for gas plants, and a state having exactly a 50-50 mix would have a standard of 1,250 pounds per megawatt hour. And we used their constrained efficiency that assumed only 1% efficiency in 2020. So as mentioned, the main change to those scenarios was to add CHP as a new build option. Our base case results basically showed more CHP coming in on the coast in California and New York and Massachusetts and Pennsylvania and New Jersey in comparison to the policy case that I'll show you in a bit. The base case saw more CHP on the coast, probably because of higher electricity prices. In some of those states also have existing carbon trading programs. But those weren't the only places that got new CHP in the base case. You know, certainly we saw some in Michigan and Texas, Florida, et cetera. But this will be quite different from the policy case I will show you in just a minute. In terms of the total amount of CHP capacity that comes in, we saw that the increase went to 10 gigawatts for both the base and policy cases in 2030. And part of this was due to our assumption on how slow the CHP would come in. But 10 gigawatts is roughly equal to about 15 average-sized coal-fired power plants. I should also mention that that's more than some of the policies that are being considered for CHP alone, such as the 30% investment tax credit. ICF saw more CHP coming in under the 111D scenario that they ran for us than they did under that other policy. And I should also say that all of this CHP would potentially be credited under a 111D compliance plan. In terms of the different size categories, we saw more of the incremental CHP coming in the larger size categories, suggesting more of its industrial CHP, but we did see new CHP coming in all of the size classes. So here are our policy case results. I think the interesting thing here is that we saw a lot more of the incremental CHP coming in the coal-heavy regions in the Midwest and South. And we don't see any incremental CHP coming in places like California, the Northeast, places that presumably already had a carbon price in the first round. And so places that might need combined heat and power as a compliance strategy because they do have, they are coal heavy under our scenario and maybe have higher carbon prices, that's where we saw the most CHP coming in. And we did look at whether spark spread might be a key driver, and in fact, it wasn't. Most of the change, was directly attributable to the carbon price. On average, across the U.S., the carbon price is roughly $20 a ton, but for the regions where more CHP was coming in, it ranged from roughly 20 to 30, up to $32 a ton. And so the higher carbon prices did seem to result in more CHP. And just to show that spark spread sort of went in the opposite direction. Normally when electricity prices go up and natural gas prices come down, this creates more incentive for CHP. But in fact, we saw electricity prices going down under our scenario in basically every region of the country. And we also saw natural gas prices being roughly stable in every region. And so spark spread was not a key driver of the CHP results. In terms of some of the underlying changes that drove our results, this just shows the impact on new builds, new construction between 2013 and 2025 under our scenario on the right, and NRDC's moderate constrained energy efficiency case on the left. These numbers are for only through 2025 since they presented their results on that basis. And so we don't see the full 10 gigawatts here, but we show 8.8 gigawatts of new CHP coming in. It displaces mainly energy efficiency, but also some natural gas combined cycle technology. In terms of electric generation, under NRDC's scenario, they did see, big shifts towards cleaner energy generation. We saw basically those same shifts in our scenario. The main difference being that we saw slightly less natural gas combined cycle capacity, and that was replaced with new combined heat and power generation. And so that's sort of the bottom line. These changes did lead to compliance. Our scenario, of course, was designed to meet the standards that NRC had assumed in their moderate constrained efficiency scenario. It achieved results of 29.4% reduction in CO2 emissions as compared to NRDC's reference case. And these emissions reductions came at a lower cost, just slightly lower if we look at just the CHP compliance costs that covered sources would need to pay for, essentially the credit value, the overall compliance costs go down by more than 1/3 as compared to NRDC's scenario. So to our conclusions, we think CHP offers a cost-effective solution towards 111D compliance while also improving efficiency at industrial, commercial, and institutional facilities. The biggest impact is in states where there is significant technical potential, but that are also expected to have higher than average compliance costs. These are the Midwest and southern coal states. To take advantage of this opportunity, states will need to adopt a system-based approach that explicitly allows for CHP to be used as a means of compliance. And then finally, this policy alone will not achieve the President's 40-gigawatt goal, but we do think it makes a meaningful contribution. And as Jennifer mentioned, if you do add additional policies and measures at the state level, that could assist in achieving more CHP over time. The full report with all the graphs that I've showed you is available on our website, and I look forward to answering any questions.
Wonderful. Thank you, Sara, Dan, and Stacy, for not only giving a very informative presentation, but for staying exactly within the time limits that we came up with for each of the presenters to make sure that we did have time for some Q&A. I've put up on the screen now all of our contact information, and again, I encourage folks to reach out to us with additional questions that we can't cover on today's call. I'm also going to be sending out a recording of the webinar, so you'll be able to, one, see these slides and hear our remarks again, but two, also have access to some of the links for additional materials if you look kind of below the fold in the notes section of the slides. one of the things that's really striking to me, and I hinted at this in queuing up the presentations from ACEEE and CCAP, is really the very conservative assumptions about CHP acceptance rates. ACEEE assumes a 50% acceptance rate for systems that have a 5-year return on investment, and CCAP assumes that same 50% acceptance rate in the industrial sector for systems that have a 2-year payback period. As folks in the industry know, 2 years is very ambitious. I often tell people it takes 7 to 10 years to pay back a CHP system. What that suggests to me then is that states can adopt policies in their compliance plans that can help shrink that payback period. If a state had complementary policies like reducing standby rates or a streamlined interconnection process or a state grant program, all of those things would make it so that projects are paid for more quickly. And if that were done, then you would have even greater uptake from either the ACEEE or CCAP scenarios. But I want to turn to Sara, Dan, and Stacy to see if you have any thoughts about what types of policies could states adopt that would lead to even more ambitious projections, and I think the very encouraging results you already found in your studies. We'll start with Sara.
I'm actually going to let Dan take that because he really is our CHP expert here.
Yeah, well, there's a couple of things. I think one big one could be just either requiring or allowing CHP to satisfy a renewable or energy efficiency or advanced energy portfolio standard in the state, just as a way to get more, not just business, commercial industrial institutions interested in it, but getting the utilities themselves really interested in supporting that and helping that happen, because that's one of the larger barriers is they can not just supplying interconnection and all of that, but also providing incentives or on that side as well could help a lot.
I would agree. In states like Massachusetts that have renewable portfolio standards that include combined heat and power have been more effective in encouraging and driving more CHP in their states. Similarly, streamlined interconnection standards, as was done in Maine, can have an impact there as well.
And is there anything, at the end of the day, it's up to the states to develop plans to achieve their targets. What can be done to encourage those types of favorable policies in state plans? We've got a large group of stakeholders on the line right now. What kind of steps can we take, or what kind of steps could EPA take to try to get those types of actions incorporated into state policy?
Well, Jennifer, Neil Elliott with ACEEE. I think the one thing that you alluded to in your opening remarks is quantifying and actually giving value to some of the benefits in terms of resiliency, grid reliability, avoided investments on the transmission distribution infrastructure. At this point, when Dan and the rest of the team did the analysis for ACEEE, we did not give any credit to those benefits in terms of the economics. I think that could be a big factor in this because we currently are not giving any value to those.
This is Sara. Jennifer, can I add that I think in the near term something EPA could do if you wanted to encourage states under this rulemaking would be to issue some guidance and clarity for how states could take credit for CHP in a way that EPA would be receptive to.
Great point. And if there are states on the line, there are some, I don't know if guidance is such a loaded term, but there are some fact sheets or backgrounders that EPA has put out that talk about how you can quantify the emissions benefits from CHP, how you can measure thermal output, examples of other states that have done it that I think would provide a good resource to states. But I agree, something that's kind of clearly packaged as being part of 111D guidance would be very helpful.
And I think in this context, it's important to figure out how much of the emissions are assigned to the electricity portion of CHP as opposed to the boiler part itself in order to to have consistent approaches, ideally, across states.
I have another question for both of you. What was the most surprising result of your study?
I mean, I think for us at CCAP, I think the most surprising thing was the big difference in terms of the location of where we saw the new CHP coming in. The fact that under the policy scenario, we did see a lot more in the coal states was what we had hoped to see, and we were glad to see that. I think we would have liked to see more overall CHP than what we did see, but I think that some of the conservative assumptions were, make it more of a low-end estimate of what's possible.
Yeah, I would agree with that. I think that the way that the data that we got for our analysis showed so much of the potential being clustered in New York and in California, I expect to be a little bit more spread out. And then I think just the overall number being relatively low, especially compared to the president's goal of 40 gigawatts by 2020, we give it an extra 10 years and get halfway there. But this is without doing a whole lot of extra stuff. So it kind of speaks to the need to of how much more work there is to do to achieve large-scale CHP in the country.
Right, but I think that, and maybe this is an optimistic way to close our call as we hit the top of the hour. I think that 111D really leaves the door wide open for that. I can't remember exactly your wording, Dan, but that whole bunch of extra stuff to help push CHP forward. I mean, I actually think that your results were, the results of both studies were very encouraging, that this rule alone has the potential of getting us a substantial way toward achieving that 40 gigawatt goal. And with favorable policies which could be credited under the state compliance plans, you could get even more. So I think that now we turn to the states to figure out what actually is going into those plans, and to also ask EPA for the type of guidance that Stacey just flagged that is needed also to make sure that states have the tools that they need to develop those plans. But with that, thank you so much to everybody for calling and for your questions and for your interest in this. And we will be following up, as I said, with links to the recording and the slides.
Thank you.